Hi folks, this is the worksheet that we worked on 2 weeks ago. Level 1, page 1 of the worksheet. Blah, blah, blah. Here's a density. That's nice. This density is often useful. Blah, blah, blah. Minutes, drops per second, minutes. Good. Suppose one drop is 50 microliters. This dot here indicates that the 50 is two significant figures, all right? It indicates that the 0 is significant. What would be the mass of one drop of ether? Okay, so mass. We're looking for grams. So here's grams. Let's see. Change color. Point. Bigger pencil. All right. 0.637 grams, 7, per 1 cubic centimeter. Now, it happens to be the case that 1 cubic centimeter equals 1 milliliter. And it happens to be the case that 1 milliliter equals 1,000 microliters, but you don't need to necessarily know that. You can just convert this to liters. So let me do so. So 1,000 milliliters equals 1 liter, and 1 liter equals 1 million microliters, and we have a certain number of microliters in this drop. 50 microliters. Okay, I knew to arrange the units in this way because I know I'm looking for grams. So I start with the thing that has grams, and then I keep on converting units using whatever information I need and ignoring the information I don't need. I keep on converting units until I can get rid of the centimeters cubed. But I know that the other piece of information in this problem is 50 microliters, and that's going to be important. So I can use 50 microliters to get rid of the last bit of unit, which is the microliter here. This is 0.637 times 1,000 times 50 divided by a million. Whoops. 0.637 times 1,000 times 50 divided by 1e6. It's going to be 0.0319. I guess I can't undo the inadvertent movement here, so let's see, I guess I'll have to use the, can I use the, yeah, this is good. Alright, so 0.0319. Now, the answer was 0.0319, but you see I only have two significant figures right there, so I can only say 0.032 grams. I'll put a box around my answer so that Glenn can easily grade. Except that I'm not grading these worksheets, of course. What would be the mass of 12 drops of ether? Well, if that's 1 drop of ether, then 12 drops of ether. Okay, so the mass, 0.032 grams, and this is 1 drop. And then what is the mass of 12 drops? Drops. So 0.032 times 12, 0.038. By the way, folks, this here is the measurement. There are two significant figures here. This here is not a measurement. This is a count. You do not consider the significant figures when there is a count. And the reason is, there is nothing uncertain about a count. If you counted 12 drops, the last digit, the 2 there, was not a guess, the way the 2 here is a guess. You know, with measurements that we do in the lab, you always guess the last digit. Yeah. So here you count significant figures, but here you do not, because there are no digits here. That was a guess. All right. So blah 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 blah. What are you asking for? How many grams of ether? Okay. So I know that it is 0.032 grams in a drop. So let's see. 0.032 grams in one drop. How many grams of ether would you need for the first 5 minutes of induction? Let's see. First 5 minutes, 12 drops per minute. During induction, 12 drops per minute. All right, so this is 12 drops per minute. So 12 drops in 1 minute. And the first 5 minutes are for induction for this guy. 5 minutes. Okay. So drops. All right. Now it looks like minutes. This is going to be grams of ether for the first 5 minutes of induction, right? So 0.032 times 12 times 5. 0.032 times 12 times 5. That's 1.92. That's 1. Oh, now what about the significant figures here? Do we consider 5 minutes as one significant figure? No, we don't. And the reason is you do not actually count minutes, do you? Minutes are shown on a stopwatch or a clock, and those things are not physically counted. A clock or a stopwatch will show you the following. This is minutes, this is seconds, and then there are tenths of seconds and hundredths of seconds. So this is what the stopwatch display will show you. And a clock will just show you, a clock has actual like tick marks, right? So minutes have to be measured, not counted. So because the problem does not say 5.00 minutes or 5.0 minutes, because neither of those things are said in the problem, it's just 5 minutes, you have to say that this is one significant figure. Now, I'm not a doctor, so I don't know if this is actually how an anesthesiologist measures out the ether. But this problem is measuring the ether out by drops, and it's measuring the minutes out with one significant figure. So we have to stick to that one significant figure. Well, okay. Just trying to clean this up here for you. Okay, there we go. So it is not 1.9. Well, okay, it was 1.9, but oops. I undid all that. Okay, so it isn't 1.9. It's going to be 2 grams of ether. That's for induction. Now let's do this for the next 5 minutes, which are for loss of consciousness. So just draw a line here. So for loss of consciousness, it is 1 drop per second, right? So 1 drop is 0.032 grams. That's a drop. Now it's 1 drop per second. So 1 drop in 1 second. And this is for 5 minutes. So there are 60 seconds in 1 minute. And seconds are gone. And there are 5 minutes. Drops cancel. So we have grams left. So this is 0.032 times 60 times 5. That's going to be 9.6, but again, there's only one significant figure here because minutes, you cannot really count like complete minutes. So the answer is 10. So the answer was 9.6, but we can only have one significant figure, and so the answer is 10 grams. So the last 50 minutes are just 20 drops per minute. So maybe I can do this in a different color so you don't get confused here. About blue. So the next, I'll do it right here. Right? So the next 50 minutes, so 0.032 grams. There are several different ways to do this, of course. I'm just doing one of the ways, one of the many possible ways. I don't mind which way you use, as long as you can show the work on the exam and get the right answer, and trim the significant figures. So the last 50 minutes are just 20 drops. So 20 drops per minute. Drops cancel, minutes need to cancel, so multiply by 50 minutes. Multiply by 50 minutes. So then minutes cancel. This is minutes on top, this is minutes on the bottom. 0.032 times 22 times 50. 0.032 times 20 times 50. So that's 32. But again, there's only one significant figure, so this is 30. So this is going to equal 30 grams. So the answer is 30 plus 10 plus 2 grams. That's going to be 42 grams, except this number only has the tens place. The ones place is not significant. That means the answer can only have the tens place. That means the answer is not 42 grams. The answer is 40 grams. So this is about 40 grams. About 40 grams could be 38 grams, 39 grams, 40 grams, 41, 42, 43, 44, could even be 35 grams. So this is very approximate, right? Now, of course, if you were a real doctor, I don't think this is how you would do it at all. I think you would have to do some other calculation based on the mass of the patient, because like a 50 kilogram patient is going to need much less ether, I think, than, let's say, a 200 kilogram patient. I don't think there is such a thing as a 200. So a 100 kilogram patient would need much less ether to get under than a 50 kilogram patient. So I think this problem is just a bit fanciful. But that's okay. It's a good exercise in unit conversions and interpreting the problem. Let's see, President Obama's dog. I might. That was just number one. I'll do number two, and then I'll do a new video for the rest of them. So here's President Obama's dog. He wants this plastic dog in liters. So here's liters right here. It's milliliters, so I'll start with liters. 1 liter is 1,000 milliliters. And let's see, I got 1 milliliter is 1.32 grams. There we go. And then, what about these grams? Yes, the dog weighs 55 pounds. So there are about 454 grams in 1 pound. This data I didn't put in the problem, sorry, but I gave this in class, 454 grams per pound for this problem. And then the dog weighs 55 pounds. Don't worry, on the exam you will be given data like this that you are not intended to memorize. These, pounds, they're not SI or even metric, so you'll be given those if necessary. 454 times 55 divided by 1,000 divided by 1.32. 54. So I got 18.9. And there are only two significant figures here, so you can only say 19. I mean, if it was 18.9, you can only say 19. 19 what? Everything is canceled out except for liters, so 19 liters. That is a sizable plastic replica. It is correct. 454 times 55 divided by 1,000 divided by 1.32. Yes, it is. Okay. That is pretty big for a piece of plastic. Okay, I'm going to stop this video now, and then I'll continue on a new video. Thank you.